Alrighty, welcome everyone to day 12 of Advent to Code. Hopefully this video today goes much better than yesterday. Yesterday's video was just a disaster all around between my microphone not working, me screwing up, and misreading part 2. It just didn't go well, so here's hoping today's goes better. I mean, honestly though, yesterday's wasn't too bad minus messing up, misreading that part 2. Otherwise, it was all pretty fine. Like, I actually did the problem pretty fine, so at any rate, 20 seconds here until day 12 starts. Fingers crossed that today's problem isn't that bad. I've been enjoying these so far. The questions have been a little bit awkward for me to read or a little bit hard for me to read and understand, but overall the problems themselves weren't all that bad. So, at any rate, 5 seconds here. What are we going to get for day 12? Let's go. Your ferry made decent progress towards the island, but the storm comes in faster than expected. The ferry needs to take evasive actions. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving the route directly to safety, it produces extremely circuitous instructions. You have to use the PA system to ask if anyone can help you. Quickly volunteer. Of course we do. Navigation instructions puzzle input consists of a square, single character actions prepared with integer values. Okay. It probably mean is N means north. North by given value means left by given degrees, right by given degrees, forward. Interesting. The ship starts by facing east. Only the left and right actions change the direction the ship is facing. That is, if the ship is facing east, the next instruction N12, the ship would move north 10 units, would still move east. Of the following actions were F. What? As the ship is facing east, the next instruction is north 10. The ship would move north 10 units, but would still move east. To the following in action were F. It would move the ship 10 units east because the ship starts facing east. The ship 3 units north. Okay, so it's just facing. Interesting. All right. Manhattan destines some of the absolute values of its east-west positions and its north-south position. Okay, figure out where the navigation instructions lead. So this one should be pretty easy, actually. So we just need to take this, dump this into here, and we need to just go about parsing these. So what we're going to do is we're going to store our int x position is going to be 0, or int y position is going to be 0 as well. And we also need a little enum down here for facing. So public enum facing, or it's called direction. And it's going to have north, north, south, east, and west. It's just a way for us to know where we're facing. And then we can have a direction facing, and it starts at east. Direction. Oh, my typing's hard. Facing east. Okay. So now what we're going to do is we're going to go through each instruction, string S, and input strings here. And we're going to first parse this. So this is going to be, the first bit is going to be where we're going. So we're actually going to do a switch statement on S char ant 0, because it's actually pretty easy. And we can just go case by case. So first case, we're going to handle the cardinal directions first because they're going to be the easiest. So north is just going to, actually we should do this. We should do int amount is going to equal s dot substring, first parse integer, parseInt s substring from 1 on. So this is going to be the amount we're going. So of course the first character is our value. We're going off of northeast, southwest, forward, left, right, and then amount is how much, and that's just the rest of it. So in case of north, we're going to just increase y by amount. This is going to be the case for all of these. So north, east, south, and west are really easy to deal with. South is going to be minus, east is x plus, and this is x minus. Okay, so now we dealt with north, east, south, west. Now we just need the left, right, and forward. So forward is going to be the next easiest. This one is just going to have another if statement. Or I guess what we could do actually, we could have each of these directions have an x, y value. So north is going to be 0, 1. south, east, and west. South is going to be a -1, east is going to be 1, 0, and west will be -1, 0. And what we can do down here is we can do private, whoops, int x, call this x off, int y off, and we can do direction takes in these values. Obviously, you're going to be like that. And then now what we can do is we can use these. Oh, didn't like that. Okay. And so we do this dot x off equals x off. This dot y off equals y off. So now by doing this, we can now just adjust them by providing them values, which is much, much easier. So now in the case of forward, all we need to do is we just need to do direction. We just need to do, oh, I need to break some of these, by the way, because we don't want these bleeding into the next case, making our life much easier, or much more difficult, sorry. And all we need to do now is we just need to do x plus minus facing dot x off times amount, and then facing y off times amount. Makes our life much easier. So there is the forward case. Now all that's left is the left and right. So left is going to be degrees, right? I'm guessing it's only going to give us 90-degree rotations. Yes, probably only going to be 90-degree rotations. I would be amazed if it gives us anything else. Yeah, I'm they're based in 90s. Okay, so what we need to do is we first need to, so in the case of left, we just need to know where we're going to. So we're going to need to do int rot amount is going to equal amount divided by 90. So this is how many times we're going to rotate around. So what we're going to have to do is it's going to be, we need to know what we're kind of flipping towards. So we just need like a kind of rotate method, I guess is what it is. So it's going to be actually northeast, south. So we might be able to do this. I don't know if values goes off that, but all right. So there's a rotation amount. What we need to do is we need to do, let's do a public direction rotate direction start, and we need int amounts. And so what we need to do is we need to do while, or for loop start, for int I equals 0 while I is less than amount I plus plus. So we can go this many rotations around. What we're going to do is we're going to do another switch statement here on start. Oh, we need direction. Boolean clockwise, I'll call it. So start. So we're going to switch on start. So we can just go ahead and add each missing branch. So if for north, if quickly, we're going to, oh, we need a direction to return. So this is actually going to be on to return here. So what we're going to do is we're going to then need set to return equal equal to, if it's clockwise, it's going to be east. Otherwise, I put the wrong thing there. It is going to be west. And there we go. So now we can just do this for the rest of them. Just switch what's on this. So east, clockwise is going to be south. Otherwise, it's going to be north. South is going to be the flip of this. East and west. This is going to be the flip of this. Okay. So that should deal with that. And we can just go return to return here. And so now what we can do is we can just call this rotate method on direction. So for left, we can just call, we can do facing equals, I think it's actually facing, I think I should call it like that. It doesn't matter. It should make this static. That's what I should do. So I could just call it direction, rotate, and then we need to give it facing is what it's starting as, and then the rotation amount, which actually can just be substituted with this in. But actually I'm gonna keep this outside here just because a little bit cleaner, in my opinion, to know where if it breaks it goes wrong. And in this case, left is not clockwise. And then the last case is going to be right, which is pretty easy because it's the same exact thing, except now this is true. Oh, you're gonna throw an error, so what I'm gonna do is actually gonna put this in here because you don't like variables like that, right? Forgot switch statements. Okay, so there we go. So now that those are done, we're good. So those are rotating, fine, and then what we can do here is do the Manhattan distance, which is going to be lap of x plus y. Let's see what we get. Did we get the right answer? 894. Nope. Okay. Let's see, what did I mess up here? Facing east, only left and right action to change the direction of the ship is facing. Okay. So east is x alpha 1. So those seem to be all right. Let's see, what do we get on this example? What are we off on here? It's because it was 9. That's not right. Okay. So let me do a quick system out here. What is our x and what is our y? 17 and -8. Oh, I see. We are right, but it's the math dots absolute of these is what we messed up on. So we are right. I just didn't do the absolute for Manhattan distance. Okay, let's try this again. Good old Manhattan distance messed up. Okay, put this in. There we go. Okay, wasn't too bad. That was actually not too bad of a question. Let's continue on. Before you can get the destination to the captain, you realize that the actual action meanings were printed in the back of the instructions the whole time. And it's how to move to a waypoint which is relative to the ship's position. So north needs to move the waypoint north by the given amount. Waypoint means rotate the waypoint around the ship's. Oh my goodness. The waypoints. Wait. Almost all actions indicate how to move a waypoint which is relative to the ship's position. The action north means to move the waypoint north by the given value. Okay. Left means to rotate the waypoint around the ship. A given number of degrees. That's gonna be the hard part. Okay. For example, F10, move the ship to waypoint 10 times. Yes. Total of 100 units east and 10 units north. Wait, what? Forward means move forward to the waypoint a number of times equal to given value. Let's move forward to the waypoint. Waypoint starts 10 units east and 1 unit north. So it moves it 10 times. So you just multiply. Okay. All right. So let's go start going on part 2 here. So we're gonna copy this. Where I want to keep part 1 and part 2 separate. So just so that way I have both parts in code wise. So here's gonna be part 2. And so we're going to start x at 10, y at 1, and facing is east. Okay. There's no facing here, right? Yes, there's no facing on this. Okay. Good. So now we got to change. So these are still the same. Moves the waypoint right, but now forward. Is the waypoint 7 times, so 70 units east and then wait, so forward moves the ship to the waypoint 7 times, total of 70 units east Oh, so we're also moving the ship. So there's a waypoint and there's also a ship location. Okay. So instead of int x, we need sx and wx. We're gonna need sx, sy, and wx and wy. So this starts at 10, 1. Okay. So, there's a waypoint. Left means rotate the waypoint around the ship. Action means to move forward to the waypoint a number of times equal to a given value. So the waypoint starts. So my question is, how much does the ship move? So we have moves a ship. F10 moves a ship to the waypoint 10 times, so of 100 units east and 10 units to the north. Okay. Point stays 10 units east and 1 unit north of the ship. So the waypoint stays relative to the ship. Okay. Moves a waypoint 3 units north. To, okay, the ship remains at east 100, north 10. So I'm guessing, I don't understand the moving it 10 times. Okay, so we still know that these adjust it there, so those are fine. The forward bit is what I don't understand. It's, we just ship to the waypoint 10 times. Oh, so we go to the way, oh, okay. So we want to do ship x equals waypoint x times amount. Okay, that's what it's saying. sy, wy. Okay, that makes sense now. Okay, and so then the rotation rotates the waypoint around the ship clockwise 90 degrees. So if it goes 90 degrees, it's just gonna flip. Waypoints is at 10.4, so it's just gonna flip what they are at. So what this means is it's changing the rotation right. But what we need to know is it's adjusting the x and y. So it's going to be waypoint x. If it is even, it's just flipping it. If it's odd, it's changing which one it is. Okay. So let's just do this. Let's do for int I equals 0 while I is less than amount again. This might be easy enough to do it here. And so what we're going to do here is we're going to do every time it's going to be. Oh, but we don't know like the subtraction. Someone's going from north to here, but then it's going to go negative. Ooh. So what if you had a direction? Because if we start a direction of north, we can reuse this code. If we start at a direction of north, that's 1 on the y. Oh, but these aren't quite the same. What's the easiest way to adjust these x and y coordinates to kind of flip them around? Because left here, it's going to change them there. Okay, it's adjusting each one of these individually, isn't it? So I don't. So when it goes from south to whatever, right? It's gonna be. Because it's gonna be 4 away, but I don't know which way that's going to be that's why I don't know. So it's whenever it goes from, if it's a positive x, so if wx is greater than 0, what we can do is we just set, okay, we can do this this way. So for int I equals 0, we need this amount thing again. Okay, I think this is what we can do. Amounts, and we're just gonna kind of like do it the brute force sort of way. So waypoint x, if the waypoint x is greater than 0, it's going to switch to waypoint y, but it's going to be waypoint x times -1. Whoops, while I is less than that. Okay. Else if otherwise the waypoint x is negative, which just translates just straight to the y. It doesn't do anything there. Okay, in this case then, if the waypoint y is greater than 0, wait, so waypoint x is greater than 0. No, other way around. Wait, if waypoint x is greater than 0, it gets switched to the y. But if it's less, no, waypoint x just becomes waypoint y. It doesn't. It's only the y's that affect me going left. Because the y is positive, then goes to negative, and sorry, negative goes to positive. Okay. Wait. Wait, that was actually a lot easier than I thought it was going to be. Okay. And if we're going the opposite way, the x is going from positive, so it's now just flipping it to the x. Oh, we need to hold temp. Int temp. Sorry, we also need a temp. There we go. Okay. I think that'll work. And then there's a ship X, ship Y, and then that rotates it. Okay. And that does that. And then now we can just do again a lap of where the ship X and ship Y is. SX and SY. Maybe? Or we get 0. Okay, so... Oh, because these are changing the waypoint, not the X and Y. Try that one more time. We get that. Please be right. Dang it. Okay. Let's try their example one again. What are we off by here? So 33, and it should be that. Oh goodness. Okay. Are these right? Are these left and rights right? So left is going to always change from a positive y to a negative version of the x. And right is always going to change from a positive y to a positive x, negative y to a negative x. But it's going to be the x is changing. Okay, so that should be right. I feel like this should be right. Okay, so after every time this runs, we're just going to do a system out print line ship X, ship Y plus waypoint X plus waypoint Y. What am I getting here? So after 0, 0, That shouldn't. Why are we starting at 0? S. Oh, the waypoint starts at 10. I'm dumb. Alright, is that all we messed up? 154? Nope. South. So we're at 110 right, and then leaving the ship at east 170, north 38. Ooh, no. WX. So 10-1, 10-4. Ship X plus ship Y plus that amount. That's what we're off by. 286, 286. There we go. Now we're good. Okay. Remove that. Switch this back to our input. Run this up. What do we get as our final answer? We get that. Submit. There we go. Hey. That was pretty good. I'm actually very happy. That was not a bad question. I actually quite enjoyed that question. I didn't do all that great. Again, I'm a little bit slower trying to explain this when doing it. I'm happy if I break the top 1,000, honestly, this year. I'm pretty happy if I can break top 1,000, so that's actually not too bad. So, sweet. So, on that note, let me go through, let's explain my answer here, how I got to this, and continue from that. So, for this question, basically, we are on a ship, and we are trying to take in a bunch of instructions about how the ship moves in order to tell it where we're ending up. So on our inputs here, we are given, it's actually probably better if I go back to the question for explaining how these are. Oh, wow, okay. Anyways, so basically the actions are north, south, east, and west. That in the part 1, that changes how the boat moves and how it is. So a north of 10 means we're moving up 10 locations. East 10 means we're moving to the east 10 locations. You get it for the south and west. But then there's also left, right, and forward. In part 1, there's a concept of our facing direction for the boat. Forward just means continue on forward, and if we're facing for the certain amount it says. Left means rotate left, however many degrees, in which case they're all 90, so left means rotate left, direction-wise is the amount of times you need. Then right, same thing. And at the end, basically, we just keep firing these instructions through, and at the very end, we're getting an X and Y coordinate of where our boat is, and we're getting the Manhattan distance, which is just the X distance plus the Y distance, and we are putting that into our inputs, or as our solution. So pretty easy to do. In actual our code, it's literally just X and Y facing for each case. So north, we just increase our Y amounts, east, west, whatnot. For forward, we have a facing direction. Each facing direction has what it changes in respect to the X and Y. So for north, it's a 0, 1. For 0 for the X off, 1 for the Y off. So basically they have their offsets and what they change in terms of position wise. That way we can just multiply by how far we want to go. And for north, it'll be an X plus 0 with a Y plus the amount we will move. Nice fancy way to do it and make things clean. For the rotations, basically we call this rotate method with a given amount we want to rotate. And it just has another switch statement which has, given we are facing north, we know if we're going clockwise, we're switching to east. If we're going counterclockwise, switching to west, and it just keeps doing that pattern for how many times you say it, and then returns the final direction that it lands on. So part 1, that's all pretty self-explanatory. Just a lot of me typing things out to make things look a little bit cleaner. Honestly, today's code is probably one of the cleaner ones I'm done, so I'm actually pretty happy with that. But for part 2, though, what changes that we, instead of the ship location, we also have a waypoint location. The waypoint location is actually what's changed when we do north, south, east, and west. We are changing where the waypoint is in relation to our ship. And then also there's left and right, we'll get to the second. So now this case in forward, what forward means now is that we want to move our ship towards the waypoint a given amount of times. That waypoint, though, is still relative. So when we say move forward 2, we're actually moving from the ship to the waypoint 2 times. So it goes ship to waypoint, waypoint's also moved because it's relative, ship to waypoint again, and that's where we go from there. Left and right, however, just moves the waypoint around the ship. So instead of the ship moving directions, the waypoint would move directions, if that makes sense. And the way we do that is actually, if you think about it, if we're moving to the left or we're going counterclockwise, the x stays, or the x just becomes a y. So if the x is a positive going to left, that's just a, if the x is positive, sorry, the x is positive, I think this is backwards for you guys. I gotta look at my camera, sorry, I gotta look at my camera, sorry. If the x is positive here, all that changes if we go to rotate left, it's just now the y. If the x is negative, all it changes now the x is negative. That's hard to do. Likely, if we're going for the counterclockwise, the x is now going from a positive to a negative y, so we need to multiply by -1. If it's a negative x, it's now a positive y, so we gotta multiply by -1. Just reverse that for the y's, and that's how we know how we're moving around. It's a lot simpler when you think about it this way. I was not doing it that way initially, but at any rate, not too bad. And then that's part 1 and part 2. So honestly, I'm happy with today's question. It went pretty well. So hopefully you guys enjoyed. I'll see you next time for tomorrow for day 13. See you guys later. Peace out.